we'll go ahead and take a look at section 2.1. If you've checked your email yesterday, I did send out kind of what my lecture notes are. You don't really need them, but in terms of writing things down, it helps a little bit. Section 2.1 is all about the distance and midpoint formulas. So the distance and midpoint formulas. So the first thing we're going to do is develop the distance formula. We don't get to derive things too often in this class, so it's nice to be able to do it once in a while. What we're going to start with are 2 points. We're going to give them some generic labels. So we're going to call this point 1. So P with a little subscript of 1. And it's located at x1, comma, y1. And we're going to have a second point up here, which we're going to call P2 for point 2. And it's located at x2, y2. And again, those are subscripts. So they're not exponents. They're written down below, and they're just labeling. So it's how we're going to label our 2 points. What we're trying to find is the physical distance between those 2 points. So to do that, what we do is we kind of draw in a right triangle and look at this from a right triangle point of view. So in terms of a right triangle, this might be side A, this might be side B, and this is side D. So we know that A squared plus B squared is going to be equal to, in my case, D squared, and we need to find D. So it would really help if we could figure out what A is as a side length. Well, we know that this is x1. We know that this is over here at x2. So A is the distance between these two. So A is really x2 minus x1. And then I'm going to have to square it because of the Pythagorean theorem. I can do the same thing in order to figure out what B is. This is y1, this is y2. So the physical distance that we're moving up is going to be y2 minus y1. And that's going to be equal to D squared. However, we don't want D squared, so we'll come in and square root the both sides. So, and then I'm going to flip it just to write it as a formula. So the distance between 2 points can be found by taking the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And that's the distance formula. It's kind of handy moving forward. We're going to need it in this section. We'll need it again when we go to do our circles in next week, in fact. So, okay, I need that. So I'm going to do some erasing and rewrite the formula up top. And because it is a distance, it's always going to be a positive quantity. You should never end up with a negative quantity here. Okay. So is everybody good on the derivation of it? It's kind of nice. It's one of the few things we get to derive. So.
You mean it can only be positive in this example because we're going to the right? Like say if we were going to the left,
because it's a distance, it doesn't matter. So I just erased my picture.
Okay.
So whether I'm going from point 1 to point 2 or from point 2 to point 1, its distance is going to be positive. So if you stop and think about it, if I asked you to physically measure these two, take a ruler and put it right like that, would it really matter whether you put the 0 on the ruler on this side or the 0 on the ruler on this side? No, the distance between them is going to be the same. So that distance is always the positive quantity in terms of square rooting. So sometimes when we're solving, so last week, remember when we were solving things like x squared minus 4 equal to 0, and you set x squared equal to 4, and then you square root both sides. In that case, when you're square rooting, you added that plus or minus in. When I went to solve for the distance formula, I didn't put that plus or minus there because I knew that the distance always had to be positive. So it's one of those things when you're solving, you have to add that plus or minus in, but in this case, we only need the positive case. So again, it's like going from here to Springs or Springs to here, the distance is the same. Okay, so our first example, example 1, what we want to do is we want to find the distance between P1 is the point -4, 3, and P2 is the distance, or is the point 6, 2. Okay, now if you haven't worked with this kind of stuff in a while, which may be a while for some of you, what I'm going to do is actually physically label these points. So since this is P1, this is X1, this is Y1. This is our second point, so that's X2 and that's Y2. The reason to do that is so that you pull the right numbers into the formula as you work it. So our distance between these 2 points is going to be equal to the square root of, and now we'll pull in X2. So I labeled X2 as the 6 minus X1, which is a -4. So I have minus a -4 sitting there, and then I'm going to square it. So again, X2 was 6, X1 is a -4. So I have 6 minus a -4. Plus, and now we're going to pick up Y2, which is the 2, minus Y1, which was a 3. And we're going to have to square that. So most people get that okay. And then you have to follow your order of operations. And order of operations say do what's inside those parentheses first before we can do the exponents. So we're going to take 6 minus a -4. That's really 6 plus 4. That's going to give me a 10, which I'm going to have to square. 2 minus 3 is a -1, which we're going to have to square. Now we'll do the squaring. So 10 squared is 100, and -1 squared is 1. And then we'll add them together and get the square root of 101. And that's the physical distance between those two. Now, if that can be simplified as a radical, you need to simplify it. However, 101 is a prime number. It can't be simplified. So this is the exact answer. That's the radical. And then if they're asking for a decimal approximation, follow the directions, because sometimes they'll ask for 2 decimals, sometimes only 1 decimal. You would just go to your calculator and do the decimal approximation. So, okay, any difficulty plugging the numbers in? Because you're going to do several of those.
Okay.
Everybody good? Okay. Okay, and then the next problem we're going to work is probably one of the longest problems we do the entire semester. So example 2, what we want to do is plot each point and then form a triangle, and then we're going to verify that that triangle is indeed a right triangle. So one of the points is at -6, 3. The second point is at 3, -5. The last point is at -1, 5. So making sure I got them copied right. -6, 3, 3, -5, and -1, 5. So those 3 points form a triangle. I need to verify that they make a right triangle. So what I'm going to do is first just plot them. So I have -6, 2, 3, 4, 5, 6, +3. So there's our first point, and I'm going to label it as point A, so I've got it labeled. I have 3, 1, 2, 3, -5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's point B. And point C is at -1, 5. So it's up here. So I have my 3 points. I can see that, yes, indeed, I get a triangle, but I need to prove that they're a right triangle. So in order to prove it's a right triangle, I actually need the distance between I need the sides, which is the distance between all pairs of points. So I need to find this side up here, which would be the distance from A to C. I need to find the side that's this side over here, which would be from C to B. And then I also need the distance from A to B. So we have to do it in chunks. So to be specific, we're going to come in and find the distance from A to, let's do C first. So we're looking for this side up here. Okay. So I know I'm going to do the square root, and I always do the one that's written second minus the one that's written first. So for us, we'll do x2. In this case is a -1. That's coming from point C, minus x1, which is that -6. So I have a -1 minus a -6, and I need to square that. The next one we're going to do is the y2, which is 5, minus y1, which is 3. And then we need to clean that up. So again, the -1 minus the -6, that's really -1 plus 6. That's going to be a +5 that I have to square. 5 minus 3 is 2, which we're going to have to square. 5 squared is 25. 2 squared is 4. And I end up with the square root of 29. That does not simplify. There's nothing that divides into 29. It's a prime number again. But I have one side length up there. So I end up with the square root of 29. I'm going to go ahead and label it on my picture because I'm going to have to erase. So over here, we know that this is the square root of 29. So there's one of my sides. Okay. Let's go find another pair. And it doesn't matter in what order you do them. You just have to find all of them. So let's do the distance from C to B. And you'll notice what I'm doing is walking around my triangle just to be logical in my brain. Okay, so we're going to do B is x2, C is x1. So we're going to do 3 minus a minus 1. Y2 is going to be that -5 minus the 5. It doesn't matter which way you do the points as long as you're consistent. So whatever was the first coordinate in the parentheses has to pair up with the first coordinate in the second set of parentheses. So in other words, the 3 and the -5 are coming from the same point. The -1 and the other 5 are coming from the other point. Okay, so cleaning that up, 3 minus a minus 1 is 4. 4 squared. The next line, I have a -5 minus 5. That's a -10. So 4 squared gives me 16. 10 squared gives me 100. That's going to be the square root of 116. Okay, this one I can simplify, and only because we haven't done one yet am I going to go through and simplify it. So what I'm going to recognize is that's 4 times what, 25, 29 maybe? Yeah, 4 times 29, 4 times 9 is 36, 8, yeah. So it's 4 times 29. So we're saying that that's the square root of 4 times the square root of 29. Well, the square root of 4 is 2. Left over on the inside is the 29. So when I simplify it, I end up with 2 times the square root of 29. We do this in 101, so I know both Matt and Adam have seen it because they had it with me. Hopefully everybody else is okay simplifying the radicals. Not, yes. Give me a holler.
Yeah.
Okay, good. So that side over here is 2 square root of 29. Okay, one more side to go. So we don't still need the distance from A to B. Again, if you want, you could call it distance from B to A. You'd get the exact same answer. It would not matter. Okay, so we're going to do 3 minus the -6. That's the change in the x's. So 3 minus a -6 plus the -5 minus the 3. Okay. So 3 minus the -6 is going to be 3 plus 6, or 9 squared. I have -5 minus 3. That's a -8 squared. So 9 squared is 81. -8 squared is a 64. And when I add those together, I'm going to end up with, what, 125? No, 145. Well, that's a strange number. I don't know that that one's going to simplify. Let's see. Grab my calculator. It doesn't divide by 2. It doesn't divide by 4. 145, does it divide by 3? Nope. Divide by anything that is going to work for us. It divides by 5. It's 5 times 29. Okay, so just as a comment, it's 5 times 29. But because the 5 doesn't simplify and the 29 doesn't simplify under the radical, I can't take the square root of 5 or the square root of 29. I might as well leave it as the square root of 145. So I investigated it, but it did me no good. Okay, so our third side on our triangle is the square root of 145. So I found all 3 side lengths. And now we're going to verify it's a right triangle, or see if it is a right triangle. So to do that, we're going to go back to that Pythagorean theorem. So a squared plus b squared equals c squared. So in terms of which side is which side, it doesn't really matter which one you call A and B, but the C is the important one, the one that's the largest, and that was that square root of 145. And even on my picture, you can see that it's the biggest one, but the largest number is always going to be isolated. So we're going to say that's the 145, which we're going to have to square. On this side, I have the square root of 29, which will square, and I have 2 times the square root of 29, which will square. So square root of 29 squared is just 29. For the next one, this is where all that radical work we did last week pays off. We know to square the 2, we're going to get a 4. To square the 29, we'll just get 29. And on the other side, we'll get 145. So we have 29. 4 times 29 was 116. And does that equal 145? And it sure does. So 29 and 116 is 145, which equals 145. So there is our proof that it's a right triangle. So, but we had to find all 3 side lengths, and that takes a while. Also on this problem in the homework, not only do they ask you to verify it's the right triangle, they want you to find the area of the triangle formed. So using that same picture and the side lengths we've already found, let's find its area. And we just talked about this yesterday. The area of a triangle we said was 1/2 the base times the height. Okay, and this is where you have to be a little nitpicky about which side you're picking up. We established that the 145 is the hypotenuse, which means that over here in the picture that side at angle C is the right angle. Why do I care about that? Well, because I need to pick up the base and the height. They're always around the right angle. So that makes one of these the base, the other one of these the height, or vice versa. It does not matter. But we're going to pick up the 2 smaller numbers to find the area. So we have 1/2 times the square root of 29. We'll use that as our base. Times 2 times the square root of 29 is our height. Well, that's a nice number. So what's going to happen here is the 1/2 and the 2 are going to cancel. You end up with the square root of 29 times the square root of 29. Well, that's the square root of 29 squared, which is just 29. So they didn't give me any units, and it drives me crazy when they don't give me units, so I'm going to call it unit squared. So inches squared, centimeter squared, miles squared, but there it is. So that's the longest problem. You only have 1 on the homework, but you do have to walk through all the parts to the problem. So, okay, any questions or comments about that?
What did you say that how the hypotenuse helps to figure the base?
Oh, so since the 145 is the longest side as the hypotenuse by definition is opposite the right angle. And the minute you have the right angle, that tells you the 2 sides on either side of the right angle. One's the base, one's the hypotenuse. And the reason for that is because the height of a triangle is defined to be the perpendicular distance from the top to bottom. Perpendicular means at a 90-degree angle. So once I've established that this is the base, then this is that perpendicular distance from top to bottom, or the other way around, if this is the base, then this is the perpendicular distance from top to bottom. So that's why I have to figure out which side's the hypotenuse first. So that makes one of the other sides our base, and the other one our height. And those are interchangeable because you can flip the triangle around. Other comments or questions? Okay. Rich is really good about asking questions. Everybody else feels comfortable, right? You would ask if you had a question.
Yeah, I'm good.
Okay. Thank you. Okay, then we're going to go on, and we're going to use that distance formula to solve another problem. So this is example 3. We want to find all points that have a y-coordinate of -3, whose distance from the point is 13. So from the point 1, 2 is 13. So we're going to find all the points that have a y-coordinate of -3, whose distance from the point 1, 2 is 13. So you look at that and say, I have no idea what's going on there. I don't know what they're asking about. So what we're going to do is draw a picture to try and get a handle of what's going on. So the first thing I'm going to do is go plot the point 1, 2. So 1, 2, which is right there. Okay, we have a point that has a y-coordinate of -3. So y-coordinate of -3 is down here somewhere, right? So here's -3. And it's 13 units from 1, 2. So what I'm going to do is I'm just going to pick a generic point out here. I don't know where this point is, but I do know that this distance is 13. So it's pretty far away in order to get that unit of 13. What do we know about that point? Well, all we know is that the y-coordinate's a -3. We don't know the x-coordinate, so I'm just going to call it x. So we're simply saying there's a point out there at x comma -3 that is 13 units from 1 comma 2. Okay, now immediately somebody should stop and say, wait a minute, how did I know it was on the right side? How do I know it's not on the left side of this? Well, I don't. So what there actually is there's another point over here on this side that has a negative x value and -3. Actually, we could call these x1 and this one would be x2. So there's another one over here. We're going to go find one, and in the process, the other one comes out of the wash. So, okay, what do we do? Well, we're just going to use the distance formula. So literally, we're going to plug in this, the 13, and our generic point of x into the distance formula. So, and I'm going to write the distance formula again because hopefully you're writing notes and it helps you process and memorize it. So that distance formula is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay. This time we know the distance. It's 13. They gave me that. That's going to be equal to the square root of, okay, doesn't matter in which order we do these, but one order looks better when you write things. So we're going to use this as our x minus the 1. I'm going to get rid of my little x1 so we're not confusing anybody. So I'm going to use x minus the 1 quantity squared. So again, that's this x coordinate minus this x coordinate plus, in the same order, we'll pick up the -3 and subtract the 2. And now all we have to do is go solve it for x, which is why we spent time last week solving some equations. Okay, there's a long way to do this and there's an easy way to do this. We're going to go the easy way. Let's clean up a little bit on the inside. So I'm going to have 13 is equal to the square root of x minus 1 squared plus -3 minus 2 is a -5, and a -5 squared is 25. So the -3 minus the 2 gives me a -5. When I square it, I get a positive 25. Okay, well, at this point, I could FOIL out this and try and collect like terms, but I'm not going to. Instead, I'm going to use what we did last week. We're solving a radical equation. So let's just come in and square both sides. So 13 squared is 169. That's going to be equal to the x minus 1 quantity squared plus 25. Well, we need to solve for x. I'd still rather not FOIL that out if I don't have to. So I'm going to subtract the 25. So that gives me 144 is equal to x minus 1 squared. Okay, well now we're going to square root both sides in order to get rid of this square. And this is where solving comes back into play. I'm going to have x minus 1, but on the other side, I'm going to use plus or minus 12. What that's going to do is give me the x that's on the positive side and the x that's on the negative side. Then all we have to do is move the 1 over, and unfortunately, again, I ran out of room. So when I move my 1, what I'm going to really have is a plus or minus 12 plus 1 is equal to x. Let's split that into two possibilities. So x is equal to 12 plus 1, which comes out to be 13, or x is equal to a -12 plus 1, which comes out to be a -11. So what that's saying is that the 2 points are, one of the points is at 13 comma -3. The other point is at -11 comma -3. So I get 2 answers just like we expect, because there are 2 points that have a y coordinate of -3 that are 13 units from the given point. So that works out pretty well. So any comments or questions? You're going to do a couple of those that have slight twists like this, but follow this in terms of solving it. If you FOIL it out and try to collect like terms, you end up having to factor down here, which just makes it a longer process, and I'd rather you take the shortest method possible. Comments or questions?
No.
Good job. Yay. Okay, the other thing that's in this section is the midpoint formula. Which we do talk about in our 101 classes. So if you're coming through our 101, you've seen the midpoint formula. Okay. The only reason we need the midpoint formula is so we can work with circles next week, so it's really handy for that. I'm going to go back to that same picture I had just a few minutes ago. I've got a 0.1 that was at x1, comma y1, and a 0.2 that was at x2, comma y2. Okay, what we're looking for this time is a point that is literally halfway between the two. So this is going to be the midpoint. And what we're saying is the distance from here to here is the same as the distance from here to here. So we're looking for the point that's halfway. And when you think about this from a circle point of view, if you have 2 points that are on the edge of the circle and you're trying to find the center, this is what we can use this for. It's a lot easier than the distance formula, because literally, if you want to find something that's halfway between 2 numbers, can't you just average the numbers? So the midpoint really is an average of the coordinates. So in other words, we'll average our x coordinates and we'll average our y coordinates, because that's how you find something in the middle. So the midpoint formula simply says that it's x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, comma. Okay. So you can see that we've added them and divided by 2 for the x's, add and divide by 2 for the y's, and that's how you get a midpoint. So it's pretty nice, straightforward. It's one of the few formulas that we will see where you have a plus sign in it. One of the things you can do for chapter 2 is, because we have so many formulas in chapter 2, I would start making myself a formula sheet so that when you go to take your quiz, you've got it right there in front of you. You don't have to sit there and try and find all those formulas. So you should put the distance formula and the midpoint formula under your formula sheet. So let's go use an example of it. So this is example 4. Let's find the midpoint of the line segment that joins P1, which is the point 2, -3, and P2, which is the point 4, 2. So I've got 2 points. I want to know what's halfway between those 2 points. So I'll do the same thing that we did when we first did the distance formula. I'm going to come in and label them as an x1 and an x2. So here's x1, y1. Here's x2, y2. So I pick up the correct numbers in my formula. So the midpoint, and I'm just going to label it as midpoint, is equal to, so we'll pick up x1, which is 2, plus x2, which is 4, and then we're going to put those over a 2. We'll pick up y1, which is -3, plus y2, which is 2, and put that over a 2. So then I'm going to come in and follow my order of operations. Again, don't make sloppy mistakes. So 2 plus 4 is 6 over 2. -3 plus 2 is a -1 over 2. 6 over 2 you can simplify. We'll make that into a 3. -1 over 2 is just a -1/2. So the point that is halfway between 2, -3 and 4, 2 is the point 3, -1/2. So again, if these 2 points were on the edge of the circle, we just found the center of the circle. So, and that's the midpoint formula, also in this section. And believe it or not, that's all that's in this section. So there's not a lot, but when you start doing the homework, you're going to find that it slows you down in spots. Don't make sloppy mistakes in terms of adding and subtracting. So, okay, any question on that? The distance and midpoint.
I'm good.
How do we do for time? Yeah, about a half hour. It seems to be pretty consistent. If we were in the classroom, we'd be spending about 10 to 15 minutes going over old homework, and then we'd be doing some quick review questions, right? And that would take up our whole 50 minutes for the class. Okay, that's it. I'm good for today if you're good for today. So again, tomorrow we'll do section 2.2, and on Thursday we're going to talk about those review to date problems, and I'll help you with some of them. So again, by Thursday I want you to have at least looked at those review to date worksheet that's in module 1, so that you can ask which questions. So I'll be glad to help you with some, but you got to know which ones you want me to help you with. So comments, questions?
Good.
We're good? Okay, well, have a fantastic day. Enjoy that nice 90-degree weather again. Yuck. Yeah, yuck.
Inside.
Yeah, I'm going to go walk the dogs right now, exactly, because I walked them yesterday about 7, and they just about died, and they just about died. So I'm going to go do it right now while it's hopefully a little cooler than 89 degrees. So. Have a good one.
You too.
Thank you
See
too.
you. Have a good one.